Hello, future champions, and welcome. Today, we're going to crack open one of the most powerful chapters in all of mathematics, coordinate geometry. We're not just here to solve problems. Nope. We're going to build a mental toolkit that lets you see and conquer any geometry question they throw at you. Let's get right into it. Just look at this. A chessboard, right? But it's so much more. It's a coordinate plane. Every single move, the knight, the bishop, is just a change in coordinates. This is the language of location. It's literally what powers Google Maps to get you to your friend's house and what lets game designers build entire worlds. Today, you're going to become fluent in this language. So, what's our mission today? It's simple. We are going to build your toolkit with the two most important weapons you need. First up, the distance formula. Think of it as our ultimate measuring tape. Then, we've got the section formula, our precision divider. Once we've mastered these two, we'll use them to crack real exam problems just like a top ranker would. All right, let's grab our first tool. Think of this as your ultimate ruler for the coordinate plane. It lets you measure the distance between any 2 points, no matter where they are, without ever needing a physical scale. Pretty cool, huh?
So here's the fundamental question. If I give you two random points, A and B, anywhere on a graph, how in the world do you find the exact distance between them? You can't just pull out a ruler in your exam, right? We need a solid mathematical way to do it. Just think for a second. What tool have you always used to find the length of a slanted line? A hypotenuse.
And there's the secret. It's a shape you've known since you were a kid, the good old right-angled triangle. Look at this. We can connect any 2 points, A and B, by just drawing a horizontal line and a vertical line. And boom, we've got a right-angled triangle. Suddenly, that distance isn't just a random line anymore. It's the hypotenuse, and we definitely know how to find that.
Let's break it down step by step. The length of the base, that's just the difference in the x-coordinates. So, x2 minus x1. Easy enough. The height, that's the difference in the y-coordinates. y2 minus y1. Now we bring in our best friend, Pythagoras. Base squared plus height squared equals hypotenuse squared, so you get x2 minus x1 squared plus y2 minus y1 squared equals our distance squared. Just take the square root and that's it. The formula basically builds itself. When you get this logic, you will never, ever forget the formula.
And here it is, in all its glory. The distance d is the square root of x2 minus x1 squared plus y2 minus y1 squared. This is your ultimate measuring tape. Burn this image into your mind. This is the first critical tool in your toolkit, and you're going to use it all the time.
Excellent. So now we can measure the length of any road. But let's get a bit more advanced. What if we don't want the whole length? What if we need to find a spot that's exactly halfway, or maybe 2/3 of the way down that road? For that, we need our second tool.
So it's really important you know the difference here. The distance formula gives you a number, right? The total length. But the section formula, that gives you a location, the exact coordinates of a point that cuts a line. So one tells you how far, and the other pinpoints exactly where. Okay, I know this one can look a little intimidating at first, but trust me, it's super logical. It helps us find the exact coordinates of a point, P, that splits a line in a specific ratio, like M1 to M2. Think of it like this. You're driving from city A to city B. This formula tells you the exact GPS coordinates of a coffee shop that's, say, 3/4 of the way there. It's a precision tool. Now, there's a really common and useful special case, finding the exact middle of a line. That's when the ratio is 1:1, and look how beautifully that big formula simplifies. The M1 and M2 both just become 1. This gives us the midpoint formula. To find the middle, you just average the x-coordinates and average the y-coordinates. Simple, clean, and you'll use it constantly.
Okay, theory's done. Now for the most important part, the part that really separates the toppers from everyone else, application. Let's take these new tools and actually solve some problems. Pay close attention to how I think through these. This is how you get full marks.
Here's our first one. A nice straightforward question. Find the distance between A, 4,3, and B, 8,6. Before you even pick up your pen, what's the very first thing you should do?
You break it down. This is the habit of a champion. Trust me. What are we given? Point A, that's our x1, y1. Point B, that's our x2, y2. What do we need to find? The distance. And which formula connects what's given to what we need? The distance formula, of course. This simple table stops you from making silly mistakes.
All right,
Let's solve it. First, always write down the formula. Next, plug in the values carefully. x2 is 8, x1 is 4, y2 is 6, y1 is 3. Now we simplify. 8 minus 4 is 4, 6 minus 3 is 3. So we have the square root of 4 squared plus 3 squared. Well, 4 squared is 16, 3 squared is 9, 16 plus 9 is 25. The square root of 25 is 5. The distance is 5 units. Perfect.
Okay, on to our second tool, problem 2. We need to find the coordinates of a point. The second you see keywords like divides the line segment and ratio, you should know exactly which tool to grab from your toolkit.
Again, first step, break it down. We're given point A, 4, -3, that's x1, y1. Point B, 8, 5, that's x2, y2. And the ratio, m1 to m2, is 3 to 1. Our mission? Find the coordinates of point P. The weapon of choice? The section formula.
Okay, let's do this. Starting with the x-coordinate. It's m1 x2 plus m2 x1, so that's 3 times 8 plus 1 times 4, all divided by 3 plus 1. So that's 24 plus 4, which is 28. Divided by 4 gives us an x-coordinate of 7. Now for the y-coordinate, and be really careful here. It's m1 y2 plus m2 y1, so that's 3 times 5 plus 1 times -3. This is where students mess up. They forget the negative sign. 1 times -3 is -3. So we have 15 minus 3, which is 12. 12 divided by 4 is 3. So our final answer, the point is P of 7, 3.
I've shown you how to use the tools. Now it's your turn. This is where the real learning happens. So grab your notebook and solve these yourself. Don't just watch me do it. You have to do the work. Let's go. Here are your first 3. Number 1 is a nice warm-up MCQ. Number 2 is a straightforward distance formula question. Just be careful with those negative signs. And number 3 is a direct practice for the section formula. Pause and give them a real try.
Let's crank up the difficulty just a bit. Question 4 is a great one. It makes you work backward. You have the answer for the distance, and you have to find a missing coordinate. You'll need to solve for y. And number 5 is a classic. Are 3 points collinear? Meaning, do they all lie on one straight line? Here's a hint. If A, B, and C are on a line, what's the relationship between the lengths AB, BC, and AC?
And for our last one, a real-world scenario that uses the exact same logic as question 5. Look at this classroom. We've got students at A, B, and C. Are they sitting in a perfectly straight line? You can't just guess. You have to justify your answer with calculations. Show your work.
Okay, quick recap. Today, we filled our toolkit with 2 super powerful formulas. The distance formula, which is just Pythagoras in disguise to measure any length, and the section formula to find a precise point on a line. The biggest takeaway? Don't just memorize them. Understand why they work and when to use each one.
And remember this, every big rank, every dream college is built on small, consistent efforts, just like the one you put in today. You've taken a huge step in mastering this chapter. Don't stop now. Keep practicing, keep solving, and you will get there. Well done today.